Capacitive transducer is a passive transducer. They are passive transducer used for sensing displacement, and they are also primary transducers. So, they are passive, so they need an external supply, and they are the passive transducers. Capacitive transducers sensors are extensively used in industrial and scientific applications. They are based on changes in capacitance in response to physical variations. Due to the change in the physical variation, there is a change in the capacitance of the material. These sensors find many diverse applications, but main are related to the measurement of displacement. So, the main application of these type of transducer is the measurement of displacement. These are the various types of capacitors and capacitive transducers. Capacitive transducers measure the displacement by measuring the change in capacitance. The value of capacitance C is given as epsilon A upon D, where C is the capacitance in farads, A is the area of cross section of plates in meter square, D is the distance between two plates in meters, and epsilon is the dielectric constant. So, there are three parameters on which the value of capacitance C depends, that is epsilon, that is dielectric constant of the material, A is the cross sectional area of the plates in meter square, and D is the distance between two plates in meters. So, there is change in the capacitance when there is change in the overlapped area of plates. Either there is change in the distance between the two plates, or there is change in the dielectric medium, or capacitance may be changed either mechanically or electronically. These changes can be occurred either mechanically or electronically. Changes are change in the area, change in the distance, or change in the dielectric material constant. The variable capacitance used to convert physical phenomena into electrical signal is called a variable capacitor transducer. As there are no moving parts in, so there is no wear and tear, so their life expectancy quoted is 200 years. They have very long life, but the major problem with these type of transducer is their high impedance, which makes them very susceptible to noise. So, they are very widely greatly affected by the noise. Advantage of capacitive transducer: they are having low hysteresis, good linearity, highly sensitive, stability, repeatability, resolution as small as 0.003 mm can be obtained, static pressure measurement capability. Along with these advantages, there are some disadvantages also. First is high impedance output, high temperature sensitivity, need for complex electronics, and fourth one is the dirt. With the dust or dirt, the output also varies. Capacitive transducers are also used for the measurement of thickness. Capacitive transducers can also be used to measure the thickness of the material. This method of measuring thickness is used in the case the material to be tested is an insulator. So, the material whose thickness is to be tested must be an insulator, and this material is placed in between the two metal plates, forming a parallel plate capacitor. The material whose thickness is to be measured is placed between these two parallel plates. So, there is a diagram in which there are two parallel plates. First, this is a ground plate, this is another plate, and this plate, upper plate is movable. So, with this movable, there is a dielectric material whose thickness is to be measured is placed between these two plates. As we already discussed that capacitance of the parallel plate capacitor is given by C is equal to epsilon A divided by D, where A is the cross sectional area in meter square, D is the distance between two plates in meters, and epsilon is the dielectric constant. So, in this case, when we place a material between two plates, its thickness varies, its distance varies, and by varying the distance, which is directly calibrated with the thickness of the material, we can calculate the variable capacitance. And this variable capacitance, which depends upon the distance between plates D, gives us the thickness of the material to be measured. Another application of this variable capacitive transducer is the dielectric gauge, that is used for the liquid level measurement. Capacitive transducers can be used in liquids and free flowing solids for continuous level measurement. Material placed between the plates of a capacitor increase the capacitance by the factor epsilon, known as the dielectric constant of the material. When two capacitor plates are partially immersed in a non-conductive liquid, the new capacitance CD is a capacitance when we immerse these two plates in a non-conductive liquid, is given as Ca multiplied by epsilon multiplied by D plus Ca divided by R, where Ca is the capacitance with no liquid. So, Ca is the original capacitance without any liquid. Epsilon is again the dielectric constant of the liquid. Epsilon is the dielectric constant of the non-conductive liquid in which these two plates are immersed. R is the height of the plates. D is the depth or level of the liquid between two plates. So, when two plates are immersed in the non-conductive liquid, the new capacitance CD is given as Ca multiplied by epsilon multiplied by D plus Ca divided by R, where Ca is the capacitance without liquid, epsilon is the dielectric constant of the liquid, D is the depth or level of the liquid between plates, and R is the height of plates. So, there are large variations in the dielectric constant with temperature, so that temperature correction may be needed. According to that this formula, D is given as CD minus Ca into R divided by epsilon Ca. So, by these parameters we can get the value of D. D is the depth or level of the liquid. This type of sensors are widely used for chemical and petrochemical industries and can be used for wide range of temperature, that is -40 to 200 degrees centigrade, and pressure variation, that is 25 to 60 kg per centimeter square. Third type of transducers are the variable inductance type transducers. Inductance is another property of electric circuits which can be used in transducers. If a length of wire is wound into a coil and electric current passes through it, a magnetic field is generated, that is EMI. If that current varies, the magnetic field also varies, and it induces other current, some current in the coil, and this induced current opposes the original current. So, this phenomenon is known as electromagnetic induction. This self-inductance, that is the self-inductance, is the property of the coil due to which it opposes the original current. Self-inductance is a measure of this effect and is given by L is equal to N² μ₀μᵐ N²A upon L Henries, where N is the number of turns in the coil, A is the cross sectional area of the coil in meter square, L is the length of coil in meters, μ0 is the permeability of free space, that is vacuum, that is fixed, that is 4 pi into 10 to the power minus 7 Henry per meter, whereas mu r, this parameter, is the relative permeability. It depends upon the material. So N is the number of turns of the coil wound over the conductor. Mu0 is the absolute permeability. Its value is fixed, 4 pi into 10 to the power minus 7. Mu r is the relative permeability that varies with the material. A is the cross sectional area of the coil in meter square, and L is the length. One of the example of variable inductive type of transistor is LVDT, linear variable differential transducer. It is used for the measurement of displacement. It is a passive transducer. Supply is provided to middle coil and output is taken from the other two coils. There are three coils. Supply is provided to middle coil and output is taken from the other two coils. Differential amplifier is used to measure the differential output from the windings, and the output is in an AC waveform. So there is three coils. So supply is given to the middle coil. So the supply is given to that middle coil, that is AC excitation voltage, and output is gathered from the other two coils, AC output voltage. The core is movable. Why use LVDT? What are the advantages of LVDT? First is the friction free operation. No mechanical contact between core and coil. Generally there is no mechanical contact between core and coil, so there is no chance of any type of friction. Infinite mechanical life, infinite resolution, electromagnetic coupling, limited only by electrical noise, low risk of damage. Most LVDTs have open bore holes. Then again there is null point repeatability, zero displacement can be measured. Single axis sensitivity, effects of other axes are not felt on the axis of interest. Environmentally robust, stable, strong sensors, good for structural engineering tests. So these are used for the structural engineering tests because they are mechanically very much strong. In the null position, the basic principle is that in the null position, the magnetic field generates current of equal magnitude in two coils. The two coils having same current in the zero position. When the core is moved, there will be more flux in one coil as compared to other coil. This variation in the current results in the variation of voltage. This variation in voltages is linearly proportional to displacement of coil. So when the core is moved, there is a variation in the currents in two coils, and this variation current results in the variation of voltages, and this variation in voltage gives us the displacement. These are three coils. P is the primary coil to which we apply a supply. S1 and S2 are the secondary coils for the output. Output is E1 minus E2. So in the null position, output is 0. This is the null position. When maximum right, this is the maximum left, this is the maximum right. In maximum right left, E1 is greater than E2, so output is E1 minus E2. Maximum right, E2 is greater than E1, maximum output is E2 minus E1. Advantages of LVDT: their measurement resolution is almost infinite, negligible hysteresis, high signal to noise ratio, and low output impedance. Relative to low cost, they have very low cost. No permanent damage to LVDT if measurements exceeds the desired range. Disadvantage of LVDT: there presence of harmonics due to the AC voltage. Stray capacitances also affect output. Non-zero output of low magnitude when core is in the null position. The core must contact directly or indirectly with the measured surface, which is not possible or desirable. Summary: there are some other types of transducers also, such as solid state transducer, PWM sensors, thermocouple, photoelectric devices, metallic thermometers, ultrasonic flow meters, etc. Thank you.